Good day, everybody, and we are back again together, enjoying that physical science. And today I just am continuing with that November 2020 paper. So this is last year's paper. And I'm just going to continue with it, obviously, till we get to the end. Of course, I'm trying to help you with your preparation towards the final exams, which are soon coming. And so if you haven't subscribed, please just make sure that you're part of the family. Hey, we are trying to get and chase those numbers, eh? We are a rolling and a moving train. And for those of you who might need assistance with either mathematics or physical science, you're more than welcome to send us an email, and our email address is info@mlungisinkosi.co.za. All right, let's get into question 2. Okay, so just going to move that a little bit. Okay, so they tell us that we've got a 20 kg block. Okay, that's resting on a rough horizontal surface, okay, which is connected to blocks P and Q. So blocks P and Q, there they are there, by a light inextensible string. Now remember, for those of you who have not watched our series on Newton's laws, please just do yourself a favor, because I'm going to be doing some stuff here on this question that I've already covered there. So my assumption is that you would have watched that. If you haven't, please stop this video now and go back there and make sure that you get yourself abreast with what we have already covered. Okay, so they say it's a light inextensible string. So it means when it's a light inextensible string, it just simply means that the mass of the string will not form part of the mass of the of the system. And then secondly, what it does tell us is that if we say it's inextensible, it simply means that the acceleration of this guy should be the same as the acceleration of that other block. Okay, right. So they say, okay, moving over a frictionless pulley. So we know it's a frictionless pulley. What that tells us is that the tension on the one side of the pulley should be the same as the tension on the other side of the pulley. Right, now they say blocks P and Q are glued together and have a combined mass M. All right, so there's our blocks there. Okay, so first of all, they say a force of 35 newtons is now applied to the 20 kg block, okay, at an angle of 40 degrees to the horizontal as shown. And then they tell us that the 20 kg block experiences a frictional force of magnitude 5 newtons as it moves to the right at a constant speed. Now note, they are telling us that the 20 kg block is moving to the right. Okay, so that means if we've got frictional force, our frictional force will be opposing motion and it would be to the left. Okay, right, and the first question they ask us is about the normal force. So we say the normal force, remember that we say that it's a force which a surface exerts on an object that it is in contact with, which is perpendicular to the surface. So essentially, remember that if an object is not in contact with the surface, then there is no normal force, right? All right, of course, I'm lazy to write that down. So yeah, you can just remember that. They say draw a labeled free body diagram for the 20 kg block. Okay, so let's start there. So our free body diagram for this 20 kg block, let me just bring it a little bit lower. So remember, I always advise you to draw a big fat dot. Okay, it helps. All right, so first of all, we've got the applied force there. So this is force applied. Okay, and then remember, I have got gravitational force. The earth is pulling this block down, so this is force of gravity, or you can say this is the weight. Okay, and then thirdly, we've got the tension on the string. So remember that the tension is pulling this 20 kg block in that direction. Okay, so think about it. So the 20 kg block would have been able to move faster had it not been for, you know, it being attached to that other block. Okay, so again, we said it's moving to the left, so in this case it means that frictional force is also having its part there. So we've got friction. Okay, and finally, the one that we've just talked about now, we've got the normal force that is pulling, or that is exerted by the surface on the object. Okay, so we've got a normal force over there. All right, okay, so I hope that makes sense. So let's go to the next one. Oh, by the way, this is out of 5 marks. All right, so 5 marks, we've got 5 forces. So in this case, it tells us we are on the right track. Okay, right, so they say calculate the combined mass M of the 2 blocks. All right, so they wanted to find out what is the block, or rather the mass of the 2 blocks that are combined there. So now remember, we were told that the blocks are moving at a constant speed. How does that help us? Remember, what that tells us is that it means that the acceleration of the entire system is actually 0, meaning there's no change in velocity. Remember, acceleration is change in velocity divided by change in time, isn't it? So because there's no change, what are we going to do in this case? We're going to say, well, for 2.3, right? Now let's start by, look, we've already calculated in this case, or rather we've already drawn the free body diagram for this guy, right? So I'm gonna start by taking the sum of forces on the 20 kg block. Of course, you could have taken the entire system as just one thing, right? Nothing to stop you there. All right, but I always like doing it this way so that it helps you in the future as well. So let's take the sum of forces on the 20 kg block, the horizontal forces. Now, remember, once we've got a force that is acting at an angle, that means we can always break that force down into its components. Let me just use a different color to show you those components there. Please, you don't do this when you are drawing a free body diagram, right? You keep it as it was, but I just want to show you this. We say, well, we've got a force in the x direction. So I've got a horizontal component, but I also have a vertical component. And remember, that vertical component affects our the value of our normal force, right? I'm not going to talk much about that for now. As I said, for those of you who haven't watched our videos, please go and do that. So I want to take the sum of forces in my horizontal direction. So what is the equivalent of my applied force in the horizontal? It's that horizontal component there, Fx. And to get that horizontal component, so I'm going to say, well, for 20 kg block, okay, for 20 kg block, I know that the sum of forces, or you can say F net, is equal to ma. That is where we start. That's Newton's second law. So I know that F net is equal to ma. So now, considering only horizontal forces, it's going to be, I'm taking that direction to be positive, okay, because that's the direction of motion, okay. So that means I'm going to say, with this is Fx minus the tension, okay, you can say plus minus the tension if you want to, minus the frictional force. Remember, I'm only dealing with the 20 kg block, right? And this is equal to 20, but remember, the acceleration is 0. That's important. So now let's take that Fx. Fx value is going to be F, which is the applied force. So this is 35, okay? This is on the adjacent side of that triangle, so that's cos of 40 minus the tension, which is unknown to us. This is minus the frictional force, and remember, it was given as 5 newtons, and that's equal to 0. So let's find the value of the tension. Okay, so if I take that, that's going to be 35 cos 40, okay, minus 5. All right, and what do you get there? Okay, I get a value of 21.81. I'm not going to remove all of it in my calculator. All right, so I'm not going to remove that value there, so that I can actually take it as is when I do calculation for the next one. Now obviously let's have a look at this one. What are the forces that are acting on it? Of course, I've got the tension that's pulling that P and Q upwards, but I also have gravitational force, or the weight that's pulling it down. So therefore the sum of forces for this guy, okay, remember it's moving vertically, and if that is going to the left, it's pulling this guy upwards. So this F net also is equals to MA, but the sum of forces in the vertical direction for this one, which is going to be T, going to consider direction upwards as positive, minus the force of gravity. So this is mass times gravitational acceleration, is equal to, once again, because it's moving at constant speed, this is equal to 0. So it means that T, remember it's that 21.81 value, is equal to, I'm going to just take this to the other side. I want the mass, but I know my gravitational acceleration is 9.8. So we can divide both sides by 9.8, and that's why I didn't remove that value there. Okay, I want to take it as is. So divide by 9.8, and I get a value of 2.23. I'm going to round it off to 2.23. So my mass would be 2.23 kilograms. I'm going to leave it to 2 decimal places. Of course, you read the instruction and check what the examiner has instructed you to do. Okay, and that's the value that we get. Okay, right. And once again, I did say that you could have taken this as whole system, this entire system, in which case you would have said it's going to be Fx minus the frictional force. Now the issue is that when some of you take that as the whole system, you have a tendency of forgetting to include that frictional force there, because it is also an external force. The only thing that's an action-reaction pair that's going to cancel out is the tension there, and so as a result you'll have that force minus that frictional force, but then you subtract the gravitational force, and that works quite perfectly. You can try it on your own leisure, and you'll see that you get to the same answer. All right, now let's move right along. Okay, so I'm going to move on to this side. So now they say to us, at a certain stage of motion, block Q breaks off and falls down. So which means now this mass M changes. Okay, so it means that the mass is going to be lighter. I want us to just think about it and discuss it. What would happen when the mass becomes lighter? Remember, none of the other factors change. So when that mass is lighter, it means that now one of the forces that was pulling us back is now decreased, and it means that the system would now be able to accelerate to the left for this one and upwards for this one. Okay, right, now they say to us, how will each of the following be affected when this happens? Okay, right, they say the tension on the string. Okay, I would say, well, the tension in this case would definitely decrease. Okay, and secondly, they say the velocity of the 20 kg block. Explain your answer. All right, so for the velocity of the 20 kg block, I want you to think about it. Okay, we said F net was equal to MA. Now note, in this case, what was our F net? It was the horizontal component minus the tension minus the frictional force, and this was equal to MA. Now, the moment that tension, we said tension would decrease, isn't it? So the moment that tension would decrease, okay, remember that Fx value as well as the kinetic friction would actually remain constant. It would be the same, right? And the mass obviously is the same. So what have we done? We have actually increased, by virtue of decreasing one of your forces that are opposing, I have virtually increased the net force. And an increase in net force would actually increase the acceleration, and we know that an increase in acceleration would actually increase the velocity. Okay, so in answering that, they say explain your answer. All right, you can state that tension decreases. Okay, so tension decreases, but what happens when tension decreases? It means that our Fnet value, okay, will increase. All right, and thirdly, an increase in Fnet, okay, since acceleration is directly proportional to Fnet, an increase in Fnet would increase acceleration and therefore increasing our velocity. Okay, right, and essentially that is how that cookie crumbles. Okay, I hope that it's been simple enough. I'm sure you're thinking to yourself, I can't believe physics can be so easy, right? And yes, it is. Okay, when we just know how to explain it the right way. And this is how we come to the end of this question. All right, and please don't forget to keep inviting others. Tell them your secret, eh? Tell them why you've been improving in physical science so much this year. And I hope to see you guys again next time. Shap shap.